Okay, starting chemical bonding from the beginning. You know that most of the elements are reacting with other elements atoms. Reason? Atoms of an element react with the other element atoms in order to attain stability. That means most of the elements atoms are reactive, right? You will see some elements atom are not even existing as single atomic form. They are forming molecules. So that is one more definition of atom. You know that we include what is atom. Atom is that smallest particle of an element which may or may not have independent existence but which takes part in chemical reaction. So it is the atom which is taking part in the chemical reaction. For example, if I take H2 plus O2 which gives me H2O, is this okay? It's not okay because it is not balanced. Why we need to balance it? Because atoms are neither created nor destroyed during a chemical reaction. So when the chemical reaction is taking place, first the molecules will split into individual atoms. Now these atoms will react with each other and forming the molecules, two molecules of water. You got it? So atoms are reacting and combining with other atoms so as to attain first, which is there almost in every book from the beginning you have learned, to attain nearest noble gas electronic configuration. Hydrogen shares one electron with the other hydrogen atom so that it acquires helium ka electronic. Now on these two electrons, each electron belonging to one hydrogen atom. So on these two electrons, both the hydrogen atoms have right. So now this is H2 and H2 electronic configuration is helium ka electronic configuration. So you know that group 18 elements are called noble gases because they are not reacting, they exist in atomic form. So atoms combine in such a way mostly so that they can attain nearest noble gas electronic configuration, right? Oxygen, how many electrons are there in oxygen's outermost shell, guys? How many it needs to acquire nearest noble gas electronic configuration? So it will share two electrons with the other oxygen atom. This is the Lewis dot structure. So you will see now both the oxygen will have 8 electrons in their valence shell. Do you understand lone pairs? What are the lone pairs? Those valence shell electrons which are not taking part in the bond formation are called lone electrons. When they are in pairs, we call them lone pairs. Here on one oxygen atom there are two lone pairs. Total number of lone pairs in oxygen molecule are 4. Thank you so much. Here there are 4 lone pairs. You got it? So you will be writing those valence shell electrons which do not take part in bond formation called lone pairs. So mostly mostly atoms are combining in order to get 8 electrons in their valence shell, right? That is called octet rule. Okay, so electrons are transferred or shared between two atoms such that each atom gains an electronic configuration of nearest noble gas. This is octet rule. Sorry. nearest noble gas. What is it? NS2 NP6. You will see group 18 elements, the last valence shell electronic configuration is NS2 NP6. Got it? This arrangement is called, or you can say this is considered as octet rule. Now there are certain limitations. We see there are many molecules existing and they are formed spontaneously even though they are not following the octet rule. So limitations of octet rule. The first is incomplete. Molecules having incomplete octet. Example, beryllium fluoride, BF3, AlCl3, BeH2, etc. Here if you just see beryllium, electronic configuration 2,2, atomic number 4. It has 2 electrons in the valence shell. Fluorine needs 1 electron to complete its octet. So fluorine is following the octet rule but not beryllium. The central atom is beryllium. So fluorine has 7 electrons in the valence shell. It is halogen atom, right? So each fluorine will share 1 electron. Yeah. So now this will be, this is its Lewis-Dog structure. It will be sharing like this. Each beryllium is having 4. In BeF2 molecules, beryllium will have only 4 electrons. So it is incomplete. Octet, incomplete. Then you see boron trifluoride, same thing. Boron, electronic, its atomic number is 5. Okay, you need to memorize 20 easily. So boron ka total 3 electrons in the valence shell. With each fluorine it will share 1 electron, right? Each fluorine you will show total 7. 7. I've shown for the clarity's sake with different color. And boron will have 6 electrons after sharing electrons. The central atom boron will have 6 electrons in the valence shell, right? Okay. Same thing with aluminium. Boron aluminium belong to the same group. It is called Bal Gangadhar in Tilak. One of my students gave it to me, this. Now second limitation, odd electron molecules. Odd number of electrons present. Odd electron molecules. Example, nitric oxide. In nitric oxide, if you just see, nitrogen has how many electrons in the valence shell? Atomic number 7, 2,5. Okay. Oxygen has how many electrons in the valence shell? 6. Here, oxygen needs 2, nitrogen needs 3. But nitric oxide is formed, in which nitrogen will have 7 electrons in the valence shell. This is existing. You understood? So,
It's also an example for incomplete octet, right?
That's what. Limitation, I said, limitation of octet rule. Second limitation is odd electron molecules. Existence of odd electron molecules. Now, those substances which have unpaired electrons are paramagnetic in nature. We will have the same example in molecular orbital theory as well. Okay. So, substances with unpaired electrons in their molecules are paramagnetic in nature. Third, existence of electron-rich molecules. Some molecules have more than 8 electrons. Example, SF6, PCl5, they are existing and they are stable molecules. IF7, H2SO4, etc. We'll study the least dot structure. Sulfur belongs to oxygen family. This is oxygen family. Group 16. Group 16 elements. Usse tipo. Okay. Tipo is a very in North India it is used. Tipo means copy karo. Usse copy karo. Wrong suggestion. So sulfur belongs to oxygen family. It's all oxygen family atoms. 6 electrons in the. So oxygen atomic number. So it is NS2 NP4. Can I say? They are p block elements. The last electron goes in the p shell, p subshell. So it is NS2 NP4. Everything. 1s2 2s2 2p4 for oxygen. Similarly, this will be. This is in second period. This will be in third period. So N stands for period number. So this will be 3s2 3p4. This is 4s2 4p4, like that. So you can write this is 2s. This is general electronic configuration of group 16 elements. 2s2 2p4, 3s2 3p4, 4s2 4p4, 5s2 5p4. Here N represents the period number. That's it. Okay. Now sulfur has 6 electrons in the valence shell. I'm making with crosses. 1, 2, 3, 4, 5, 6. It will share 1 electron with each fluorine. It can expand its octet. I'll explain you why some elements able to expand their octet, because they have vacant d orbitals. Those elements which have sulfur belongs to third period. Third period means third shell starts. In third shell SPD, 3 subshells exist in the third shell. So 3D is vacant. So from third period onwards, you will see many elements can expand their octet because they have vacant d orbital. So fluorine 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So then you circle them. Here, each fluorine will never expand because it is belonging to period 2. It can have only 2 shell, and in the second shell no 2d exists. 2d doesn't exist, so it does not have vacant d orbital. Fluorine will never expand its octet. No period 2 element can expand its octet. Third period onwards can expand their octet. And sulfur has 12 electrons. Can you see after sharing? 12 electrons in sulfur's valence shell. Got it? Same thing for phosphorus. In PCl5, each chlorine will complete its octet, but phosphorus will have 10 electrons after sharing its 5 valence electrons with 5 chlorine atoms. Right? Now structure of sulfuric acid. Here also expansion of octet is taking place. Actually 2 structures are accepted for sulfuric acid. Okay. So one is this. It's a dibasic acid. Oxygen. Sulfur is the central atom. 2 oxygen are either bonded through double bond or a coordinate covalent bond. What does that mean? Here 1, 2, 3, 4, 5, 6. 6 electrons in the valence shell. One structure accepted by a group of people is this. Each oxygen sharing 2 electrons which are only bonded to sulfur. The other oxygen atom sharing one electron with sulfur and 1 electron with the hydrogen. Hydrogen I should show with which color? Take blue color for hydrogen. 2, 3, 4, 5, 6. You got it? So in this you will see total how many electrons in sulfur ka surrounding? See? Yeah. So one is this structure. Each oxygen has 8 electrons. I made here mistake, so here H O S double bond O. It's a dibasic acid. Please remember this. It is also called oxy acid. Oxy acids are those in which oxygen, some other non-metallic element and hydrogen present. Those hydrogens which are attached to oxygen are replaceable. That means they will be coming out as proton when these acids are dissolved in water. Okay. So hydrogen. Another structure is here expansion of octet. Sulfur has expanded octet in this structure. One more structure which is also accepted is this one. Here no expansion of octet is taking place. Okay, different school people have different views on these two things, but I did not find anywhere which is more accepted. If you know, then please let me know also. So here what happens, there is a coordinate covalent bond formed. Sulfur is getting satisfied by receiving electrons from one oxygen which are bonded to the hydrogen. So here sulfur octet is complete, oxygen octet is also complete. In coordinate covalent bond, you know that for one shared pair, or you can say to make one covalent bond, both the electrons are coming from single atom. That is called coordinate covalent bond. When both the electrons to make single covalent bond coming from one atom, that is called coordinate covalent bond. This is hydrogen, something like this. So here you will show it something like this. SOOH. In this, no expansion of octet. Hydrogen's duplet is complete and oxygen octet is complete. Even sulfur octet is complete in this. Next limitation is noble gas compounds. Noble gas have 8 electrons in their valence shell. Still they can form compounds. Xenon and krypton, you will see heavier noble gases. Okay, because when you go down the group, tendency to lose electron increases, metallic character increases. So it's easy to make compounds of xenon and krypton. Xenon difluoride, xenon tetrafluoride, XeO F2 F4 and krypton F2 etc. They exist. Expansion of octet is taking place definitely. Fifth, there are other drawbacks. This theory cannot, octet theory cannot explain the shape of the molecule. It cannot explain stability stability of molecules, and also the energetics. It cannot explain the energy changes taking place during bond formation. Energy changes during bond formation. Lewis and Cossell gave this octet rule theory, or octet rule you can say. Next is how electrovalent bond or ionic bond is formed and the factors affecting the formation of ionic bond. It is also called electrovalent. Electrons are exchanged. Then one atom is turning into cation and another atom is turning into anion, and they both will attract each other with the electrostatic force of attraction. Okay, so two atoms take part in the bond formation by by losing and accepting electrons. One atom which is electropositive, the one which loses electron is called electropositive. One atom electropositive loses electron, and the other one which is electronegative accepts electron. Example, if I take formation of sodium chloride, sodium will lose electron turning into a cation. Chlorine will accept electron turning into fluoride ion, which is anion. Cations and anions are named based on the respective electrode where they get discharged after electrolysis. You got it? Cations, those ions which during electrolysis move towards cathode. So cathode पे पहुंचने वाले ions cations. Those ions which move towards anode are called anions. Anode is positively charged electrode. Anions are negatively charged ions. Which are so negatively charged ions, which are anions getting discharged at anode. Got it? Now we will take factors affecting formation of electrovalent bond. In this, the first, see, I told you one atom is turning into cation. Cation means the electron is lost. So to take out electron from an atom, we provide some energy which is called ionization energy. Okay, so the first factor is, I should write ionization energy. That means one atom should easily turn into cations. So the atom which turning into cation must have low value of ionization energy. Got it? So then it will turn easily into cation. Second, electron affinity. Can anyone tell me what is electron affinity?
Which is more electromagnetic than
Higher
attracts
chances.
There is no relation between electron affinity and electronegativity.
Higher chance of gaining.
Okay, in a way that determines that a higher chance of gaining electron. But what is electron affinity? If someone asks you what is define electron affinity, what do you say?
the atom that
The energy released when an electron is added to an isolated gaseous atom. So that energy released is taken as electron affinity for that atom. Do you know even alkali metals and alkaline earth metals, even energy is released when they accept electrons, except noble gases. For every other element, the electron gain energy is negative. That enthalpy is negative because energy is always released. And whenever during a process energy is released, that process is spontaneous. Do you know that? We have done it in thermodynamics chapter, right? During any process, when overall energy is released, that is called spontaneous process, gives energy. Criteria for spontaneity, gives energy release, right? Free energy. So what is electron affinity? This determines tendency to form an anion. Okay, if you want to write the definition for electron affinity, it is equal to the amount of energy released when an electron is added to an isolated gaseous atom. Isolated gaseous atom means the electron is not experiencing any other force, okay, other than the atom itself. So that's why we are taking isolated gaseous atom. In order to calculate absolute value of electron affinity for a given atom, the atom has to be isolated. Okay, it should not experience any other repulsive or attractive force. Gaseous atom. So it is also called electron gain enthalpy. Representation, it is represented by delta EGH. Its value is negative because energy is released. Okay, now greater the negative value of electron gain enthalpy, that means more energy is released, more easily an ion is formed. Third criteria or the factors which is affecting the formation of electrovalent bond is lattice energy or lattice enthalpy. So when oppositely charged ions come together to form 1 mole of the solid crystal, electrovalent crystal, that energy released is called lattice enthalpy. Are you getting? So when oppositely charged ions come together to form 1 mole of crystal lattice, then energy is released, which is called lattice enthalpy or simply lattice energy. More the magnitude of this released energy, more is the stability of the final ionic compound form, and greater is the chance for the formation of that ionic compound. So during any spontaneous process, more is the magnitude of release energy, more is the spontaneity, or you can say more easily that reaction will take place. You understood? So here, suppose X plus Y minus in gaseous form, 1 mole of anions, 1 mole of cations, they come together forming 1 mole. So plus whatever energy is released, this is called delta EGH, and its value is negative. Higher the magnitude of lattice enthalpy, greater is the tendency to form ionic bond. Right? So greater is the tendency to form. Now there are two factors given in your book, factors which affect the lattice enthalpy now. Okay, so two major factors affecting lattice enthalpy. Affecting lattice enthalpy. Okay, the first is charge on ions. More the charge, more will be the force of attraction. More the charge on anions, more will be the force of attraction between the ions. That means it is directly proportional to the charge. So for example, if you compare sodium chloride, calcium chloride, calcium has 2 unit positive charge, sodium has 1 unit positive charge. We are fixing the anion, and if you have magnesium oxide, here 2 plus 2 minus, right? This is 2 plus 2 minus, this is 2 plus 1 minus, 1 plus 1 minus. This is the order of the lattice enthalpies. It is minus 758, I think. Yeah, minus 758 kilojoule when 1 mole NaCl is synthesized. This is minus 2254 kilojoule. This much energy is released when 1 mole of calcium chloride is forming crystal lattice. This is minus 3932 kilojoule per mole. Here both cations and anions have greater charge. Here only one cation is having more charge. An ion is 1 unit negative charge. Here this is 1 plus and 1 minus. So do you see? More the charge, more will be the energy release, or more will be the lattice enthalpy. Right? Second factor is size of ions. See, I'll tell you, okay, in physics you will learn next year in electrostatics chapter. The electrostatic force is directly proportional to the charges product, cation and anion charge, divided by square of the internuclear distance. It is called inverse square law. Okay, so most of the natural forces except nuclear force, electrostatic force of attraction, magnetic force, gravitational force, they all follow inverse square rule. Okay, so it is, the force is directly proportional to 1 by the distance between the two particles, square of the distance between two particles. So that is called inverse square law. So size of the ions, if the size is more, what will happen? If the size is bigger, positive, negative, so the internuclear distance will be increasing, the force value will decrease. Are you getting? So more the size, more will be the internuclear distance, and smaller will be the electrostatic force of attraction. So if you just compare NaCl, Na plus Cl minus, okay, and then NaBr, you know that what is the order? Halogen family: fluorine, chlorine, bromine, iodine. So when you go down, the group size increases, atomic size increases, right? So NaBr, so this will have higher value of lattice enthalpy than this, and then this one. Properties of ionic compounds, the next topic. Properties of ionic compounds or electrovalent compounds. Okay, the first, they are crystalline in nature. What do you mean by the ions are arranged in a definite pattern in the crystal, so they form crystal lattices. Now high melting and, because of the strong electrostatic force of attraction, high melting and boiling point. High melting and boiling points due to strong electrostatic force of attraction. Hard and brittle in nature. In solid state, they do not conduct electricity. Only in the molten state, when ions are free to move about, or in the solution state, they can conduct electricity. In solid state, they do not conduct electricity. In molten or in solution, they conduct electricity. Now they are soluble in polar solvent, like dissolves like, so there are like two charges, means two poles, positive pole, negative pole, like that. So they are soluble in polar solvents. Example, can you tell me polar solvent? Water. Okay, so in water, hydrogen has partial positive charge, oxygen has partial negative charge, and insoluble in non-polar solvents. Please remember, ionic bonds are non-directional. See, covalent bonds are directional, but ionic bonds are non-directional. Non-directional means the two ions can attract each other in all possible direction in 3 dimensions. They are attracting in all possible direction. So when the bonds are non-directional, okay, then configurational isomerism, when we study the isomerism chapter, you will understand. So thus they do not show configurational isomerism. That is the important feature or important characteristic of covalent bond containing compounds, configurational isomerism. You might have heard example, geometrical
I'm sorry.
and optical isomerism. That is shown by covalent compounds.
Non-directional means they
Uh, greater the charge, greater is the force of attraction between positive and negative ions, and thus lesser is the tendency to get into the. So you can write a note. Okay, so for solubility, greater is the charge on cation and anion, greater is the attraction force, and smaller is the tendency to go in the solution, or you can say lesser solubility for those ionic compounds. For example, if you fix one ion, suppose anion I fix, so BaCl2 and AlCl3. Here the charge +1, +2, +3. So charge is increasing in this direction. Charge increases. Okay. And solubility increases in this direction. You got it? More the charge, more will be the attraction force between the ions. So less chance is for solubility. Got it? Now covalent bond formation. So here actually the force of attraction developed by the sharing of electrons between the combining atoms. Okay, so you can say the force of attraction developed when two atoms share electrons with each other. Okay, it is called covalent bond. Mostly it is formed between two electronegative atoms. Mostly formed between two electronegative atoms. Now the shared pair of electrons are called bond pair of electrons. Shared pair of electrons are called bond pair. Of electrons, and those electrons of valence shell of combining atoms which are not taking part in bond formation are called lone electrons. And when you are taking them in pair or lone pair of electrons, one pair of valence electrons which are not taking part are called lone pair, otherwise lone electrons. Example, HCl molecule, hydrogen plus chlorine this is HCl.
Sorry.
There is sorry, what did you say?
45 minutes after class ends. We have bio on Monday.
That's fine, we have time. It's only Wednesday, sir. It's fine. So not all covalent bonds are purely covalent. Similarly, not all ionic bonds are purely ionic. Do you know that? Okay, so covalent characters in ionic bond, there were certain rules given by Sir Fazan. So Fazan's rule, which describes covalent character in ionic bonds. So they are saying when a cation approaches an anion, the cation tends to distort the electron cloud of anion, okay, and attract it towards itself. This process is called polarization. This process is called polarization. Are you getting? And the power of cations to distort the electron cloud of an ion is called polarizing power. The power of cations to distort the electron cloud of anions is called polarizing power. And the ability of an ion to get distorted is called polarizability. So due to which what happens, the electron clouds are getting overlapped and partial covalent characters develop. Okay, due to this partial overlapping of electron cloud, takes place, which results into formation of covalent characteristic. Now, Fazan gave the factors which are favoring polarization, or factors favoring polarization. The first, small size of cation. Okay, small cations have high nuclear charge density okay, thus they tend to distort or polarize the electron cloud of an ion to a greater extent. You got it? So I can say lithium chloride is more covalent than sodium chloride, and potassium chloride is more covalent than sodium chloride. KCl more covalent than sodium chloride. उल्टा कर दिया क्या? wait a minute, LiCl is more covalent than, and उल्टा कर दिया. Second is large size of an ion. So what will happen when the anion size is larger? So greater is the polarizability, because nucleus of large anion will have less hold on the electron cloud. If anion size is larger, suppose this is nucleus and this is anion and one is this. So now this will attract, this is suppose the boundary of electron cloud. So there is no such boundary electron cloud. So this will have lesser attraction force, right? This represents electron cloud. So more chances of getting distorted. This has less chance of getting distorted. You got it? If I put a cation here, so there is less chance, because an ion's own nucleus is pulling electrons towards itself if the size is small, and here the anion size is bigger, so nucleus will be attracting the electron cloud. Okay, the outermost electron or the valence shell electrons are less attracted towards the nucleus because of the bigger size. So more chances that cation will distort the electron cloud. So more distortion. Here less distortion. Larger the anion, greater is the polarizability. So lithium iodide will be more covalent than lithium bromide. See, I am changing only anions. Then lithium chloride, then lithium fluoride. Third is high charge on cation and anion. See, more the charge on the anion, you know that bigger is its size. We have done it in periodic classification chapter, right? More the charge on cation, smaller is the size. So, right, more the charge on cation. If I remove 2 electrons for isoelectronic species, if you remember the order was so. Here, higher the charge on cation,
3 copies, no?
higher the charge on cation, greater is the polarizing power. Hence, more is the covalent characteristic. If you compare NaCl, it is +1, then magnesium chloride +2, then aluminium chloride, on aluminium it's +3. Cations are same. So polarizing power, sodium lesser than magnesium, lesser than aluminium. Am I right? No, wait, I have to give you cation example as well. So similarly, greater the charge on anion, more is the polarizability, because anion sizes increases when the charge on anion increases. You know that. Okay. So please remember, anion size increases with charge. So if I have to compare, fluoride is of lesser size than oxide, then nitride. So if I have to compare, lithium fluoride is more covalent. Lithium fluoride, the charge on, yeah. Lithium oxide and lithium nitride. What will be the order? Next is electronic configuration also affects the covalent characteristics in ionic compound. Electronic configuration of the cation. When two ions have same size, when two cations have same size and same charge, then the cation with pseudo inert gas electronic configuration, I'll explain you what is it. Any cation with this electronic configuration, NS2 NP6 and ND10. Are you getting? Or inert pair configuration, which is D10N plus 1 S2, okay, having high polarizing power. Then the one with noble gas electronic configuration. Got it? So CuCl is more covalent because here the charge is +1. Cuprous chloride is more. Copper shows two valencies, +1 cuprous, +2 cupric. More covalent than NaCl because Cu plus has pseudo inert gas configuration. Cu plus electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6 and 3d10. Copper is 3d10 4s1, right? So one electron will go always from the outermost shell, which is 4s. So then it will become 3d10. Got it? Quickly I'll take characteristics of covalent compounds. First, they have very low melting and boiling point, okay, and they are soft and less brittle than ionic compounds. Covalent bond strength is lesser than the electrovalent bond strength. Covalent bond strength is lesser than the electrovalent bond strength. Second point is they have lower melting point and boiling point than electrovalent compounds. Again, reason is same. Covalent bond strength is lesser than the electrovalent bond strength. Insoluble in polar solvents except polar covalent compounds. In bracket you write except polar covalent compounds. एग्जाम्पल मालूम है? H2O is polar covalent. Ammonia is polar covalent. Insoluble in polar solvents and soluble in non-polar solvents. All organic compounds are dissolved in organic solvents. Neither in solid or in molten state in molten state they conduct electricity. That means they do not conduct electricity at all. Because they do not furnish ions. Because they do not furnish ions. Okay, but there are exceptions to this. Certain polar covalent compounds like HCl, okay, when they are dissolved in water they furnish ions. Exception: HCl, which is polar covalent. Polar covalent means when the shared pair is more directed towards one atom, which is more electronegative. Okay, HCl, polar covalent, ionizes in water and furnishes H plus and Cl minus ions, thus conduct electricity. The reactions do not involve ions and they are slower than the ionic reactions. These reactions are called molecular reactions. It's not like the molecule taking part in the chemical reaction. The molecule will first split into atoms and then those atoms will take part in the... but to distinguish it from the ionic reactions, they are called molecular reactions. Okay, their reactions are considered as molecular reactions. Now, the covalent bond is directional in nature. Due to this reason, they show isomerism. Next bond is coordinate bond. It is actually a special case of covalent bond only. It is a special case of covalent bond. So when during formation of covalent bond, both the shared electrons are contributed by one atom, or you can say one of the bonded atom. The covalent bond is known as coordinate bond. Got it? Now the one which donates the pair of electron is called donor atom. Okay, it is shown like this. So this is called donor atom, and this is called acceptor atom. That is how you show it. A, B, like this. Example, formation of ammonium ion. What is it? Ammonium ion. The condition for the formation of the coordinate bond means the central atom must have one lone pair. So here nitrogen in ammonia is having one lone pair. If you just see the Lewis dot structure. So when ammonia is allowed to pass through water, you know that. So then water which is having little bit quantity of hydrogen ion. So this hydrogen ions are getting attracted towards the lone pair and attack on the lone pair, and you will get ammonium ion. This is shown like this. Now this positive charge, always you will see that the one which is donating, we are giving positive charge to that and negative charge. There is no actual charge separation though, but this is just the representation. Okay, so now that overall charge, since the left hand side the total charge in the reaction is +1, so now this one will acquire, hydrogen will acquire the negative charge, plus minus getting cancelled. Ammonia ka nitrogen will acquire the positive charge after donating the electron. So this is called ammonium ion. Here nitrogen will have the positive charge now. Other examples, hydronium ion, H3O plus. Okay, in fact in ozone there is one coordinate covalent bond. Here oxygen, 3 oxygen, 2 oxygen atoms are sharing 2 electrons, forming a double bond, something like this. And oxygen cannot expand its octet, you know that. The third oxygen will just be the receiver. It is something like this. The middle oxygen atom is octet is completed. The one which is doubly bonded, that octet is also completed. So it is shown something like this. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. And 2 electrons here, 2 electrons here. This is ozone. Now what are the conditions for the formation of coordinate bond? First, donor atom must have one lone pair of electrons to donate. Second, acceptor atom must have one empty orbital to accept. Must have one empty orbital to accept the electrons. It's a special case of covalent bond only. So all the characteristics of covalent compounds shown by compounds having coordinate bond. Okay, it is a special case of covalent bond. Thus, compounds with coordinate bonds show similar characteristics as shown by covalent compounds.